Right, so we're here at the International Workshop of the International Council of Systems Engineering, INCOSE, here in Seville, Spain, and we're great to be joined with Michael Watson, who's the President-Elect of INCOSE. So welcome, Michael. Great to see you.
Thank you, Joshua.
So what's it like being the President-Elect of INCOSE?
It's a lot of fun. You get to engage with a lot of really good people. You get involved in a lot of different topics in systems engineering and have some influence, not so much in those topics, but in helping facilitate the progression of those topics to help enable people to move forward in the discipline, which is just it's a great feeling and a great experience to have.
And what got you to choose to take on that role? I mean, I imagine it's a very large amount of your time and energy has to go into this.
It is. I have a large interest in advancing the discipline of systems engineering. I've been working on that for a number of years. Spent 8 years at NASA leading the NASA Systems Engineering Research Consortium, all about searching for the engineering basis of systems engineering and how do we take the next steps forward. We have a really good set of processes defined, which tells us how to organize our work, but what's the basis of being really truly successful in our work, right? To make sure that the systems that we're producing are systems that are what's needed and perform in the ways that we intend for them to do, right?
Yes.
And so what can we do to move forward in a lot of different areas? And that's what we did with the NASA Systems Engineering Research Consortium. What I wanted to do was bring that in and get that communicated out to a broader audience, not just NASA. And so I joined INCOSE to do that.
Fantastic.
Began to chair the Complex Systems Working Group and had some effect on that. Put together a set of systems engineering principles that came out of the NASA work and had INCOSE release that in August of 2022. Led the team that kind of took the NASA work and formulated that into an INCOSE product, which was a really engaging experience working with a lot of great intellectual minds in systems engineering. So when the opportunity for president came up, Carrie Lunny called me up and said, "Hey, Mike, would you be interested?" And I said, "Sure," because it's another opportunity to kind of help see the organization grow and see how the discipline can move forward. And be the trusted authority in the world that we are trying to establish and give people a place where they can come to get the really expert knowledge on systems engineering that you need when you're out in the workplace, when you're trying to practice systems engineering.
Because at the end of the day, it is about delivering value, delivering systems that people want to. A system shouldn't just exist for its own purpose. It should exist to do things that move society in a positive direction.
Correct. And how do we ensure that we're giving that right value, right? What do we need to look at to ensure that?
So talking about that research project you mentioned at NASA, so we have a copy of, I believe this would be the final reports that you came out with?
Yes, the technical publications. Yes.
And so it's the Engineering Elegant Systems, the theory of systems engineering with yourself, Michael Watson at Marshall Flight Center in Huntsville, Alabama. What was the origin of doing this research project?
Well, that's a great question. If you look at the preface in the document, actually touch on that to a certain extent.
Yes.
But it came out of a talk with Mike Griffin when he was at the University of Alabama in Huntsville. I went over to see him about my thoughts on systems engineering and understand a little bit better his thoughts. In the midst of that conversation, we had some very similar ideas about how we thought systems engineering should be practiced, where we thought directions that it might need to move, where we thought maybe the engineering basis would come from, or at least an idea of how to start looking for that, and the approach. And in that conversation, we decided it would be great if we had a group of universities that could come together and form that. So I took that back to NASA, and NASA said, yes, we would sponsor that activity. And so we formed this consortium that over 8 years had 17 different universities involved and made a lot of progress, right? The principles that INCOSE published in 2022, the NASA version are in these publications, and that's an initial step into getting to the real engineering basis of systems engineering.
And you touched on there about Michael Griffin, who he was the director of NASA.
NASA administrator, yes.
Which is a presidential appointment to control the entire agency. And so I imagine his knowledge of that whole organization, which must be one of the leaders of applying systems engineering in the world, and the fact that he wanted to engage in this report suggests it's very, very important for an organization like NASA.
Oh, it's tremendously important. Space Shuttle gets into orbit with a whole lot of engineers, of which systems engineering is crucial to help integrate those activities together. It was essential for the Ares 1X and the Constellation program. It's certainly a cornerstone piece of the Space Launch System.
Which is the replacement for the shuttle.
Yes. In fact, you can look at the organizational structure that we initially started with on the SLS program was actually an idea that came from the lead systems engineer, who brought that forward into program management and said, this is a good way to fix the communication problems we saw in the previous program. Let's set ourselves up this way. The chief engineer agreed with it, the program manager agreed with it, and the program implemented it. And that's where systems engineering is really, really important, right? To kind of bring in those needs, bring things forward to program management, and you work together as a partnership and make that happen. And so it's essential for NASA and flying in space.
Yes.
Space is a very unforgiving environment. You make a mistake, you lose everything.
Yes.
You can't pull over on the side of the road and wait for a tow truck. That doesn't happen. So it's a essential piece of what NASA does.
And so of the report, have there been changes that have aspects of it been implemented?
That's still emerging.
Yeah.
It's being looked at. The principles are probably the biggest thing that provide guidance into it. And the principles that we used influenced some of the editing updates that I was a part of for the NASA Systems Engineering Handbook. In fact, you'll see the principles actually called out now in the INCOSE Handbook.
Yes.
And so, so it's starting to make an impact.
And changing very large organizations or even small organizations is incredibly difficult, and it takes huge amounts of effort over a long period of time, but certainly is possible.
It does, yes. And what the principles do is provide guidance on how to appropriately apply the processes. Is one aspect that they do. They also provide the basis for further research into the engineering underpinnings of systems engineering.
How are you finding, so there's lots of changes in the space industry. We have, I think, hugely valuable new systems, be it the Starlink constellation, where I personally have one of those dishes, and I think it's incredible that you have high-speed internet essentially anywhere on the planet and enabled by space technologies. But how do you see the sort of potential changes in the space industry?
Oh, wow, it's going really fast. It's really exciting to see commercial space kind of emerging and being successful. It's not one company, it's 10 or so that are out there being successful with rockets, with satellite platforms, with different things. It's no longer large companies or government-funded large projects at the larger proms. It's small companies, startup companies, people with a new idea coming up, people in different countries providing launch systems. And that's it's opening the window now for space to be more commercially accessible and not just through government organizations. And that shows an advancement in the market of spaceflight, which is hugely important for us to start to see more benefits from access to space. Resources that are on other planetary bodies is the next step. How do we access those? So seeing the growth of the commercial industry is a huge step forward in space development.
Yes, and I sort of almost view it with, say, aviation or automotive. initially you might have one organization that could create something, and now we have plethora of many. And I'm not saying you go to low Earth orbit is easy, but that type of capability is becoming much more common, and then the big national agencies can move on to the next thing, whether that is the man on Mars or these phenomenally difficult challenges.
Right.
But I would like to see that we are, as a species, able to do those things, because even Earth's lifespan is unto itself finite,
Right.
And we do have a responsibility to explore the universe.
Yes, yes, and the aviation model is a really good one, right? I've looked at that some. You go from the Wright brothers to 20 years later, we've got a nascent airline industry, and emerging cargo flights are becoming more regular. Post office is making use of aircraft. It's becoming reliable enough to make use. Now, that was 20 years. Space, first rockets launched in the early 1950s. 20 years later, we're landing on the moon. But that commercial element of reliable, dependable, we're sending cargo is just now emerging, right? It was another 20 years before we saw that. So it's going at a different pace, but it's following the same basic paradigm of how it evolves, right? So I used to say 10 years ago that commercial space was in the barnstorming phase. There were a lot of experimental rockets that some worked, some didn't. Companies were struggling a little bit. It was hit or miss. And we've jumped from that directly into kind of where the aviation was in the 30s, where you've got more reliable aircraft. The DC-3 came out of the 1930s. That aircraft is still in operation today. Right? Wow. People still fly them. Yeah. And so we're seeing some elements of that. I can't tell you what the DC-3 of spaceflight is yet, but that is coming into play, and we're seeing that industry grow along parallel lines, but at a slower pace, because space is harder to access. And so it takes more effort, more planning, more resources in order to be able to achieve that.
Yes. And certainly, I visited the SpaceX facility in Hawthorne in Los Angeles, and it was incredible to essentially see a production line of, these were the Falcon 9,
right.
And the phenomenal number of them and the reuse. And it seems that the space shuttle was designed for reuse. My understanding, it had challenges associated with that, but
right.
It was visionary to try and to. My understanding, the challenge with the reuse of the space shuttle was the maintenance and the inspection, the resurface after flight was intense and made it cost somewhat.
Right. If you look at the space shuttle initial concept studies, I've got a picture from one of those reports where you see a shuttle parked in a hangar with basically airline stairs pulled up against it. That was the concept, right? That it would be that easy to maintain. There wouldn't be a lot of after-flight maintenance.
So like when we fly on a 747, they essentially fuel it up and go off again.
That was the idea. But that didn't come about. The technology to make it, to achieve that level, wasn't quite there yet. And so you saw a whole lot of refurbishment, mainly of the tiles, but of all the systems. Engines had to be rebuilt, tiles had to be replaced. And so I was in the orbiter processing facility a few times, and you could hardly see the orbiter because it's surrounded by this mass of gantries all the way around it. So that's not the same as a rolling set of stairs up against the hatch, right? Yeah. So we didn't quite get to where we wanted to be in the initial concept, but we made huge progress in what it took to enable the next steps for that, right? And that's what we're looking for. SpaceX is trying to take another step with their Starship.
Yeah.
They have been able to successfully re-enter it now, which is important. And we'll have to see where they go and how close they get to that model. So, yeah.
And there's never any harm in trying these things and using them to build onto the next thing. I think often people can be a little critical if, say, the space shuttle didn't achieve what it maybe fully set out to with all that reusability, but became a stepping stone for what we can
Right.
have today.
And you do see that from commercial space. I don't know how much people are aware of that, but there's a lot of engine technology, rocket technology that commercial space uses that was basically technology transfers from NASA. NASA developed it over the last 50 years, and a company comes up and they needed some help, either testing or, do you have an initial design we can look at? And all of that information was actually fed by NASA. Similar to what you saw in the aircraft industry with NACA and providing a whole lot of testing information that then fed into the aircraft design. You're seeing sort of a similar effect happening now.
And essentially, that's a good thing. The
Yes.
fact that society can take some tax money and allocate it to research, but research that potentially one individual commercial entity couldn't afford, or maybe doesn't have that long-term roadmap where they can afford it. And, people even talk around organizations like Bell Labs and how AT&T, or the sort of American telephone monopoly or very large entity, could afford to do basic research, which could then go on to develop transistors and
all kinds of technologies that the smartphone that we're talking with now is based on that.
Exactly. So if you were to be advising a younger person who is interested in either systems or space or engineering in general, what would you say to them?
Follow your passion. You need to get an engineering degree that allows you to do where your interests flow, whether that's aerospace or electrical, mechanical, chemical materials, whatever your interest is. Systems engineering is a new degree area for some universities. And so if you want to do systems, look for those degrees, right? Look for the universities that offer those. And so that's an important thing. But then also know what paths you want to follow, right? There's more than one path. You could don't set yourself out and say, I want to work for SpaceX, right? And then if that doesn't work out, because there aren't a lot of jobs, right, at any one company, if that doesn't work out, then you're like, well, I'm done. Set yourself up, I want to work in commercial space, or I want to work with satellites, or I want to work with lunar techniques, or Mars activities, right? Or maybe it's a little broader than that, but kind of scope yourself out, give yourself options. There's more than one path to take. Allow yourself to be able to access those paths as you make your choices and go forward with that. Having said that, do stay true to what your true interests are, right? So you have to, there's some balance that has to be done there.
So Mike, there are different pathways into engineering: vocational type training, more academic type training, research type training. What are your view on that?
Yeah, so there are a number of different pathways. You can look at the college path, and if you want to be an engineer, that's the path to get on. But if you're not interested in that, if you're thinking college isn't quite what I want to do, that's not the path for me, there are a huge number of jobs that are critical to the space industry in terms of machining. And machining critical parts, very complicated part geometries. And so we need a strong and talented core of machinists to go put that together, to assemble the rockets, to machine the parts, to make those activities or those systems work as they are supposed to. It's a critical aspect. I think when you look at a Saturn V, there were 35,000 parts. I think there were 30,000 companies involved, thereabouts, in the Saturn V program. And there are huge numbers of opportunities, not just engineering, to be involved with space.
Yes. And I think we often don't talk enough about there's the challenge of designing something on paper and computers and then bringing it into reality. And that bringing it into reality especially if you, for example, as you said, very high precision manufacturing and things where the human eye cannot tell you the difference between those two parts, but they are just in the absolute tolerances that they're operating under.
Right.
And that's one thing I would hope that we can start to appreciate more, just that challenge. And in automotive, you can design a great concept vehicle that looks very good,
right.
but then you poke around it and you're like, well, this isn't actually made very well. But translating that into something that is made very well at scale, at high volume, and at an affordable price
right.
is a phenomenally difficult challenge, but one that people should embrace.
It should, yeah. It's crucial to the success of any system, even the car, as you pointed out, that you drive down the road. Right.
So it was great to talk to you, Mike. If people would like to get more involved with INCOSE, well, actually, first of all, you can download the document right off of Google. Just type it in. I'll put a link in there and people can get the PDF. Yep. You really should. It's a big boy. I think we're at over 240 pages here, and this is double printed. So there's a phenomenal amount of information there to learn from and apply. But then, in more general, if they want to get involved with INCOSE, what should they do?
Check out the website. And there's a link to join INCOSE. There's a link just to explore the website, the working groups, the activities that we do. But through the website, then you can join. You can engage with working groups, and you can get involved. You can access products through the INCOSE store. If you join INCOSE, then the products get to you at no cost. If you're not an INCOSE member, you can still get the products. You do have to pay for those. So options for you to consider and what you like to do. We'd love to have your people out there watching that are interested in systems engineering to come join INCOSE. Help us advance the discipline. Yeah.
Well, that's great to hear, Mike. I mean, is there anything else, any parting message you'd like to give?
No, thank you very much for the invitation, and I hope your audience is excited and engaged in systems engineering.
Excellent. Thank you. Thank you, Mike.
Yeah, thank you, Josh.
Bye-bye.